Hi, this is Rick for EDU Mobile. In this demo, we're going to look at variables and constants, vars and lets. We've already talked about them. There's not that much that we need to really understand. They're very simple, actually. But let's look at this, and maybe I can point out a couple of things that are gotchas. Swift does have implicit typing, but it doesn't have automatic type conversion. This is so that typing is very strict in Swift. So here we have a var count, which is untyped. This, when we assign it a 0, count is going to be inferred to be of type int, not int8 or not uint8 or anything else. It's just going to be an int. Then I have let max annotated as an unsigned 8-bit integer equal to 10. Now this and this are not the same type, and this is easy to see. One is an int and the other is a uint8. However, when we do something like an assignment or when we try to compare count and max, this gives us an error. Why? Well, in C this would be okay because the max uint8 and the count, there would be a type conversion and those two could be compared. In Swift, there is not a type conversion implied. So in order to get these two values to be compared, we must either convert max to an int within the while check or convert count to be a uint8. So how do we do that? It can't just be like C where it's just a parent with a type inside. That would be a primitive type conversion or cast. We don't really cast in Swift. We say that we're casting the type, but what we're really doing is using the class name as a constructor to create a new value of type whatever. So let's say we're going to convert max, or this reference to max, as, and reference is a bad word, but let's say we're going to look at max as an int. We want to cast it, quote unquote, as an int. So the way we would do that is just type int, remembering that int is a class type, and then do that. So what we've done now, well, first of all, we've cleared the error, which is always a good thing. Secondly, we have cast max to be of type int so that we can compare it with count. Another way to do that, same thing, well, not quite the same thing, but you get the idea, is to cast count as an unsigned 8-bit integer, and we do it exactly the same way. And that would work as well. So there is no implicit cast typing or typecasting in Swift. We've already seen that. The above while clause will not work without converting max to an int or count to uint8. Now, this doesn't actually convert count or max. It just gets a value of the new type for purposes of comparison. So if we came out of this loop and checked the type of count after this, it would still be an int. Just as a cast in C would do the same thing. So to convert a type to another type, we use the new types constructor. For example, uint8 parent count or int max. That's pretty simple. It should be fairly obvious. We know that we can use the constructor of a class to create a new value of that class's type. This points out that primitive types in Swift are really implemented as classes. So another example, we have water temp, we have freezing, and we have boiling. So water temp is inferred as a double. Freezing and boiling are both explicitly typed to float. Now notice that we can explicitly type a value that doesn't have a decimal point, and that will be inferred, or that will be typed as a float. This is normal. If we declared in C, let's say, if we did something like this, float freezing equal 5, that would be a float, right? So this is the same kind of thing. All right, so now we've also set up a string variable. This is actually going to be inferred as a string because it's empty, but that's just a detail. Strings and cars, or strings and characters, are somewhat interchangeable. We can add up a bunch of characters to create a string. However, strings are not arrays of type character. There is a difference there. So now, if water temp is less than or equal to freezing, then state is solid. Well, what's going on here? What's going on here is water temp and freezing can't be compared in this way because they're not of the same type. So once again, we need to either convert water temp to a float for freezing or freezing to a double for water temp. So let's go this way. Float water temp. So that clears that error. And now we have the same issue in the next line. And we can convert that. And then that clears all our errors. So if it's less than or equal to the freezing value, then the state is solid. If it's greater than or equal to the boiling value, then the state is gas. Otherwise, the state is liquid, ignoring pressure variations, ignoring everything else. So then we print line water at such and such a temperature, degrees C, is a solid, liquid, or gas. Okay, also a couple of things about strings. We've already mentioned that strings, we can insert a value into a string by using the \parent construct, \parent state, \parent water temp. Also, strings are Unicode strings, so any Unicode value we can put into a string. The degree symbol is not an example of a Unicode value. The degree symbol is actually in the ASCII 255 set, but we could put anything at all in here. The simplest way to do this, if you don't know the Unicode value, we can go to Edit, Special Characters, and then insert anything we want. So, for example, we could insert this guy, or this guy, and really, it doesn't really matter. Now, when this prints out, it'll print this guy. It won't print some bizarre special symbol. So we'll go ahead and leave that there so that when we run it, we'll see it. So now, another thing to do is to look at some of the methods. And of course, we're not going to take an exhaustive poll of all of the methods of these classes, but they are there. Look at some of the methods of string. First character of state, let's say we want to pull out the first character of whatever the state is, solid, gas, or liquid. So a capital S, a capital G, or a capital L. State is a string. String has a property, starting index. We can index into a string. So state at state.startingIndex is a similar construct as indexing into an array. Now, as I've already said, strings are not quite arrays of type character, but there is an index here. We can't just say state sub 0 or state square bracket 0. We need to use the start index property or the index property of state. And then first character of state will be this state's first character, S, G, or L, and then we can print that out in the same way we print it out up here. Water temp, state, first character of state. So now that we've cleared our errors, we can run, and this will show up here in our screen. So now counts from 1 through 10. Water at 50 degrees C, or 50 degrees, smiley C is a solid, and we can see we printed out that Unicode character just fine. The first character of state is S. I almost said 5. And program ended with Xcode 0 is what we would see in C or anything else. Now, the exit code 0 means that something is getting passed back from some entry function. And we'll talk about that much later as we dig into the details of what's really going on. Thank you very much.